Number 2 here is very similar to number 1, the local extrema of a quadratic second-order polynomial, that is. Well, that was redundant, right? Quadratic polynomial, second-order polynomial mean the same thing. Occur where, now this time I formulated it as the gradient of that function is the zero vector, the vector with the component 0, 0. Now that single equation is equivalent to the system of two equations. And last time I did what some might call a fairly slick procedure of doing arithmetic between equations, and I'm going to go back to something you might have learned earlier than that. That's a little bit clumsier, but kind of, well, I'm going to call it a brute force method. So I'm going to take these two equations. The first one I'm going to rearrange it to isolate y and get y all by itself. And then what I'm going to do is I'm going to substitute that expression for y into the second equation. So that'll be 3x plus 6 times, and then y, instead of y, I'll write 6 minus 2x over 3. And then I still need to add 3, and so that's equal to 0. Okay. Then next, since the second equation only contains x, what I would like to do is collect all of the x's. Sorry, that's not just implies, that is equivalent to. Okay. Now that second equation. Let's see here. Second equation. Can I do this all in my head? I've got 3 x's. How many x's are over here? So 6 divided by 3, that's 2. So I'll have overall 2 times negative 2. That's negative 4 x's. 3 x's minus 4 x's. That's negative x. Okay, that's how many x's I have. And then I have a 6 divided by 3, that's 2. 2 times 6 is 12. 12 plus 3 is 15, and I can put that on the other side for a negative 15. Oh, and you know what? I can just do that. Okay. So I have obtained a system of equations now where x has been isolated. Okay, so y was eliminated from the second equation, and then I rearrange it to have x by itself, and then I can put that back into this first equation. Looks like sorry, spaced out there. Looks like I should write y is equal to, and can I do this in my head? 6 minus 2 times 15. That is 6 minus 30. 6 minus 30 is negative 24. Negative 24 over 3. I don't know. I got lost. 6 minus 2 times 15 over 3. This arithmetic I can do. 6 divided by 3 is 2. Minus 15 divided by 3 is 5, so this is 2 minus 10, or negative 8. Okay, so negative 8. Okay, I mean, this is just an arithmetic statement here, an arithmetic statement there. The only solution is, let's see here, 15 comma negative 8. Okay. So I did that to show you what it looks like, or to remind you what it looks like to take one equation and substitute it into the other, and then back substitute, right? After you isolate this variable, you substitute it back into the other equation. And then I want to apply the second derivative test. Since f sub xx evaluated at 15, negative 8. Now let's see, fxx. I calculated the first derivative. It's over here. The first derivative with respect to x was that. Oh, so this is simply 2. And that's greater than 0, meaning we have positive concavity, or concave up in the x direction. And the discriminant here is fxx, fyy, minus fxy squared, evaluated at 15, negative 8, and I just realized something. I am using the symbol f, but what does f refer to? On this page, there is nothing named f so far. So maybe I should take a step back and say, this is what I mean by f, a function of x and y. Alright, so now the symbol f has some meaning, and I can calculate. The second derivative with respect to x was 2, the second derivative with respect to y, let's see, a derivative of that with respect to y is 6, and subtract from it the mixed derivative. Okay, so that was derivative with respect to x, the derivative of that with respect to y is 3 squared. This is 12 minus 9, that's 3. It's greater than 0. Okay, that means that the concavity in the x direction and the concavity in the y direction are either both positive or both negative. Oh yeah, and one of them was positive, so they're both positive. And this term right here from the cross term, the xy term, didn't do enough damage to that. Since these things are both the case, f has a local, let's see, minimum or maximum. Both of these, so both fxx and fyy are positive, so that means this is a minimum of f of 15, negative 8. You know what, I feel like putting a period mark right there. I could figure out what f of 15, negative 8 is, but let's see, I'd have to put 15 squared plus 3 times 15 times negative 8. No thanks. There we go.